No, I made the move because, I was working, when I got to HP, I came with the 3Com acquisition, and I was sort of doing the CTO role for a while, and what I spent a lot of my time is looking at how we're going to provide the network solutions to cloud. And then I got involved in SDN and driving a lot of that at HP. And soon enough, I found myself mostly just doing cloud at HP and working with different groups and just getting the overall cloud thing put in place. And so it was sort of a natural move to just move over and take over that role as I was working through different groups at HP. And today, I'm strictly doing that. Obviously, as part of my role running all of Converge Cloud, it also includes, in terms of governance and with the networking team. And we have some big projects there as well around SDN for cloud. On the, we're building some interesting plugins for that on the thing formerly known as a physical, as a physics particle, now known as OpenStack networking.
Same kind of way.
I think the way I'd look at it, and again, I don't want to speak for the networking people,
Sure.
is that there is when you look at again OpenStack networking, formerly known as right, you can utilize SDN to provide some very key capabilities there in terms of multi-tenancy, flexibility, and so forth. There's nothing to prevent utilizing other things that were integrated into SDN, such as the security models, to be leveraged as well, if that makes sense.
Come from. Is there any parallels from how you've seen different networking technologies evolve, whatever they might have been, whether it was even something simple as Ethernet to how the cloud is evolving? Is there any kind of parallels you can draw from that historical experience?
The main parallel, I would say, and there's probably more of them, but the thing that comes to my mind is that the ecosystem always wins, right? And the power of the network. And if you look at OpenStack versus Ethernet, right? One of the things that goes back to Ethernet, and I think it's a better parallel to Linux, but still I like to make the parallel with Ethernet. When you look at Ethernet, right? When Ethernet came out, there were a lot of better technologies that were better in certain dimensions. They had better QoS, they had better this, they had better that. We don't even remember them now.
I remember Token Ring.
Right. Token Ring, ATM.
Why
go to Token Ring when you should ATM? MPOA, lane, right? So the point is that the meta point is that when you have an ecosystem that enough people are behind, it will, and the technology is adaptable, like OpenStack or like Ethernet. People will make it and turn it and make sure that it is the right answer because there's enough people behind it. And so I think when I look at OpenStack and I look at Ethernet, there's parallels in that concept. If there's enough people and if it's simple enough, if it's one of the nice things about OpenStack, because it's a plug-in architecture, there's a lot of flexibility. If there's enough flexibility in the architecture, right, you can adapt it to whatever things it's currently missing, so that it'll be the right answer in the future. And I think if you look at Ethernet, there's some parallels from that.
Ethernet was always a best efforts. It's and I know the Carrier Ethernet Forum has been working diligently to improve that. Would you say that OpenStack is a best efforts, or is it significantly more mature than that already?
Best effort in terms of you mean when I'm talking about parallel, I'm talking about evolution, not about capabilities.
Sure.
But I think it's a misnomer to call it best effort Ethernet, because at the end of the day, a lot of mission critical systems are running on best effort Ethernet, right? Running a lot better than on non-best effort systems. Not to mention the fact that you have database, DCB now to sort of manage that. And so, I would say the issue about OpenStack is that it's Ethernet, like OpenStack, Ethernet is designed to have failures, and so is OpenStack, right? OpenStack, the resiliency in OpenStack is built because it's designed to be able to manage failures as opposed to avoid them. And Ethernet's the same thing. Collisions will happen, we'll work around it. OpenStack's the same idea. Things will happen. OpenStack is built to be resilient. So there are some parallels, but I wouldn't take it too far because I'm sure people can find all kinds of areas to point out and say, well, that's not exactly that way, right? If you really